Okay, so let us consider an example for the probability measure. So we consider a die tossing experiment. We define the following events. A is an event where an even number occurs. B is the event where an odd number occurs. C is a number greater than 4 occurs. E1 is observed A1. EI is observed an integer I. Then, if we have omega, our omega um, is equals to 1, 2, 3, 4, 5, 6, then we can list uh, the events A. So A corresponds to the uh, even number happen. So we have the set A will consist of 2, 4, 6 numbers. B contains 1, 3, and 5. And C is the number greater than 4. So it gives us number 5 and 6. So for E1, we have the element 1. So, and then EI is equals to the I such that I is equals to 1, 2, 3, 4, 5, and 6. So we have 6 outcomes, and then you have this event. So the question is, for example, what is the probability for events A to happen? Okay, um, all right. So okay now, okay now we can find the probability for each event to occur. Okay, suppose that we give the same um, probability to each event. Then, for example, the probability of events even number to occur is can be calculated as follows. So we have the probability of A is equals to the probability of the even number. So even number is given by E2 union with E4 union with E6. So, and then this is according to the definition 11, um, we we can give the probability for each event. So probability of E2 can be plus with um, probability of E4 plus probability of E6, and therefore the so when we have since it has 6 outcomes, then we give the same probability to each event. So this means that for each event to occur, it is 1/6. Therefore, we have the probability for integer number 2 to occur is 1/6. So plus 1/6 plus 1/6, and this is equals to 3/6. which equals to 1/2. And then for another example, if what is the probability for the number greater than 4 to happen is we just take the probability of C, which is equals to the probability of E5 union with the E6, and this is equals to the probability of E5 plus probability of E6. And yeah, another again we have 1 over 6 plus 1 over 6, and this is equals to 1 over 3. Okay, and to prove that, um, uh, to prove the definition 11, so we can by referring, so by referring to the definition of probability measure, we have that, okay, probability of omega is actually equals to the probability of EI, where this is equals to the probability for integer 1 to happen plus probability of integer 2 to happen plus probability of E3 plus probability of E4 plus probability of E5 plus probability of E6, and all then, and the summation is, yeah, so since we have 1 over 6 plus 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 1 over 6, so then we actually get 1. And then um, hmm, okay, so that's for the first um, element of the definition for probability measure. And um, if we refer to the second definition, so refer to the second definition. Um, second, if we refer to the same definition but the second one, um, we can see that actually the probability of the union of the EI, where such that I is from 1 to 6, is actually equals to the probability of E1 union with E2 union with E3 union with E4 union with E6. Oops, sorry. I need to erase this. Hmm. Okay, so union with E6, and actually this is we can take the probability for each event. So this is equals to the P of E1 plus P of E2, and until probability of E6 to occur, then actually we can write this as the summation of, so the summation of all the P E I's, okay, such that I is from 1 to 6. Alright, so Um, that's all for now. Thank you.